Section 1. The Breath of the Observer and the Threshold of Night. Before we begin to count the lights in the infinite, I want you to anchor yourself in the present moment. This is a journey that requires no effort, no movement, and no heavy thought. You are currently in the safest place you can imagine. Your room is a sanctuary, a quiet cocoon separated from the rush of the world. Outside, the planet continues its relentless rotation, but here, within the walls of your resting space, time has begun to stretch and soften. Feel the weight of your body. Notice how gravity, that invisible tether that holds galaxies together, is also holding you. It is a gentle but firm embrace, pressing you into the comfort of your bed. Let your breath become the rhythm of this experience. Do not force it. Simply observe it. As you inhale, imagine you are drawing in the cool, still air of a mountain peak, far above the haze of human civilization. As you exhale, release every thought that does not belong to this moment. Let your worries dissolve like grains of salt in a deep, dark ocean. We are here to answer a question that has occupied the minds of poets, priests, and physicists since the first human looked upward and wondered. How many stars exist in the universe? To reach the answer, we must first understand the nature of the dark. When you look at the night sky from a city, you see a few scattered points of light, lonely and distant. But imagine we are moving away from the artificial glow of the streets. Imagine we are traveling to a place where the air is thin and the sky is a deep velvet obsidian. In this perfect darkness, your eyes begin to perform a biological miracle. Your pupils dilate, widening to their absolute limit, desperate to capture even the faintest, oldest photons that have spent millions of years traveling through the void just to reach your retina. This is where our journey truly begins, at the limits of human perception. On the clearest night, under the darkest skies, the human eye can see approximately 2,500 to 3,000 stars at any given time. If you were to stand on a high plateau in the Atacama Desert and slowly turn in a full circle, you might feel as though you are looking at millions. But it is an illusion of beauty. Those 3,000 stars are merely our immediate neighbors. They are the local lanterns of our celestial street. In the grand tally of the cosmos, 3,000 is a number so small it is effectively zero. Think about those 3,000 stars. They have names that sound like ancient incantations. Sirius, Betelgeuse, Rigel, Vega. They are the protagonists of our myths. For millennia, we used them to navigate our oceans, to time our harvests, and to build our religions. We projected our own shapes onto them, creating hunters, bears, and queens out of the chaos of the light. But those constellations are only flat drawings on the window pane of our reality. Behind them lies a depth that the human mind was never evolved to fully comprehend. As you lie there, imagine those 3,000 stars fading into the background. We are now engaging the power of the mind's eye, a lens far more powerful than any glass forged by human hands. We are going to look past the local sky. If you were to take a single star, like our sun, and try to understand its scale, you would realize that over 1 million Earths could fit inside it. It is a roiling, screaming sphere of plasma, held together by the crushing weight of its own gravity. Now, imagine 100 billion of those. That is the lower estimate for our home, the Milky Way. But even 100 billion is a number we say so easily that we forget what it represents. To count to 100 billion, one by one, every second, would take you over 300 years. If you had started counting the stars of our galaxy when the pyramids were being built in Egypt, you would still be counting today. You would have seen the rise and fall of Rome, the discovery of new continents, and the Industrial Revolution, all while rhythmically whispering numbers into the dark. And yet, you would not even be halfway through the stars of our own single galaxy. This is the scale of our home. But the universe is not made of just one home. It is a vast archipelago of island universes. As your breathing slows and your body feels lighter, imagine we are lifting off from the Earth. We pass the moon, a cold, silent witness to our history. We pass the planets of our solar system, those wandering jewels of gas and rock. We leave the sun behind until it is just another twinkling point in the distance, indistinguishable from the stars we once saw from our bedroom window. Now, we are in the interstellar void. It is a place of profound silence and terrifying beauty. There is no sound here, for there is no air to carry it. There is only the hum of the universe itself, the faint background radiation left over from the moment of creation. In this void, the stars are no longer just points of light. They are massive nuclear furnaces, each one a different color, a different age, a different story. Some are blue-white giants, burning their fuel with a frantic, short-lived intensity. They are the rock stars of the cosmos, living fast and dying young in spectacular explosions. Others are red dwarfs, small and humble, glowing with a dim, reddish hue. These red dwarfs are the true survivors. They burn so slowly that they can live for trillions of years. A red dwarf born today will still be shining long after our sun has turned into a cold, black cinder. The diversity of these stars is part of the count. We cannot just ask how many, we must ask what kind. For every giant star we see, there are thousands of tiny, invisible ones tucked away in the shadows. The universe is populated mostly by the quiet, the dim, and the patient. As we move deeper into this section, let the concept of distance transform. In space, distance is also time. When you look at the North Star, Polaris, you are seeing light that left its surface during the time of the Renaissance. You are looking at 430-year-old news. If Polaris were to disappear at this very moment, your descendants for several generations would still see it shining in the sky, a ghost of a star that no longer exists. This is the atmospheric reality of our counting. We are not just counting objects in space, we are counting events in time. The 200 sextillion stars we estimate to exist are spread across 13.8 billion years of history. Some have already perished, leaving behind exotic corpses like neutron stars or black holes. Others are still forming, currently nothing more than cold clouds of dust and gas waiting for the spark of gravity to ignite them. In this first movement of our journey, I want you to simply sit with the enormity of the local. Before we move to the trillions of other galaxies, we must respect the neighborhood. We must respect the 400 billion stars that share our galactic home. Imagine the Milky Way as a great glowing spiral of cream stirred into a dark cup of coffee. We are located on one of the outer swirls, a quiet suburb called the Orion Arm. From our perspective, the center of the galaxy is a thick, glowing bulge of stars, so densely packed that if we lived there, the night sky would be as bright as the day. But here, on the edge, we have the gift of the dark. We have the perspective needed to look out into the great beyond. Feel the stillness of the room again. Notice how the silence of the interstellar void matches the silence of your surroundings. You are not separate from this. The atoms in your left hand likely came from a different star than the atoms in your right hand. You are a collection of stardust that has, for a brief moment in cosmic time, gained the ability to wonder about its own origin. As we conclude this first section and prepare to dive into the specifics of our galactic neighbors, let go of the need to visualize the whole. You don't need to see 200 sextillion stars. You only need to feel the one breath you are taking right now, knowing that it is powered by the energy of a universe that is far more populated and far more beautiful than we ever dared to dream. The count is beginning. The lights are turning on, one by one, across the theater of the infinite. Section 2. The local lanterns and the solar neighborhood. Now that we have grounded ourselves in the breath of the observer and acknowledged the limits of our biological eyes, we must begin our outward expansion. We are leaving the comfort of our room and the familiar constellations. We are moving into what astronomers call the solar neighborhood, a sphere of space roughly 100 light-years in diameter. In the vast geography of the Milky Way, this 100-light-year bubble is infinitesimally small, like a single drop of water in an Olympic-sized swimming pool. Yet, within this drop, there are approximately 13,160 stars. Think of that number for a moment. From your window, you might see a few dozen. But hidden in that same patch of sky, masked by the sheer distance or their own internal dimness, are thousands upon thousands of suns. To understand the total count of the universe, we must first learn to see these invisible neighbors. The most famous of these is the Alpha Centauri system. It is our nearest neighbor, a mere 437 light-years away. In the scale of the universe, it is practically touching us, yet that touching distance is still 40 trillion kilometers. If you were to drive a car at highway speeds, it would take you 40 million years to arrive. Alpha Centauri is not just one star, but a complex family of 3. There is Alpha Centauri A, a majestic yellow star very much like our own sun, shining with a steady golden light. Then there is Alpha Centauri B, slightly smaller, slightly cooler, glowing with an orange-tinted hue. They dance around each other in a graceful orbital waltz that takes 80 years to complete. But it is the third member of the family that holds the most mystery, Proxima Centauri. Proxima is a red dwarf. It is the closest of the 3 to Earth, yet it is so faint that it was not even discovered until 1915. You cannot see our nearest neighbor with the naked eye. It is a reminder that in the cosmic census, the most common residents are often the hardest to find. Proxima is a small, huddling furnace, only about 12% the mass of our Sun. It is a flare star, prone to sudden, violent outbursts of energy that would bathe any nearby planets in harsh radiation. And yet, orbiting this temperamental little star is Proxima b, an Earth-sized world sitting in the habitable zone, where liquid water might exist. As you imagine the light of Proxima b, consider the sheer diversity of the 13,000 stars in our immediate vicinity. We often think of stars as uniform white points, but the solar neighborhood is a riot of color and scale. Only a few light-years further out, we encounter Sirius, the dog star. It is the brightest star in our night sky, a brilliant blue-white diamond located 8.6 light-years away. Sirius is a heavyweight, twice the mass of our Sun, and 25 times more luminous. Its light is so intense that it can almost feel cold, like the glint of sun on a glacier. But Sirius has a secret, a companion known as Sirius B, or the pup. Sirius B is a white dwarf, a stellar corpse no larger than the Earth but containing the entire mass of our Sun. It is so dense that a single teaspoon of its material would weigh as much as an elephant. Sirius B was once a giant star, even more massive than its partner, but it exhausted its fuel and collapsed into this ultra-dense remnant. It is a ghost haunting the bright light of its companion, a harbinger of what happens when the nuclear fire finally goes out. Moving through this neighborhood, we find Barnard's star, a lonely red dwarf just 6 light-years away. It holds the record for the fastest star in the sky, not in its actual velocity, but in how quickly it moves across our field of vision. It is galloping toward us, closing the gap every second. In about 10,000 years it will become our closest neighbor, replacing the Alpha Centauri system. Then there is Wolf 359, a star so dim and cool that its surface temperature is barely higher than that of a high-end kitchen oven. It is a huddle of heat in the frozen dark, a tiny ember that will continue to burn for hundreds of billions of years. How do we know these stars are there if we cannot see them? We use a method called stellar parallax. Imagine holding your finger in front of your face and closing one eye, then the other. Your finger seems to jump back and forth against the background. Astronomers do the same with stars. We look at a star in January when Earth is on one side of the Sun, and again in July when we are on the opposite side. This 300 million kilometer shift in our perspective makes the closest stars jump ever so slightly. This tiny jump, measured in arcseconds, a unit of angle so small it is like measuring the width of a human hair from a mile away, is the foundation of our cosmic map. It was first successfully measured in 1838 by Friedrich Bessel, and it changed everything. For the first time, we realized that the stars weren't just up there, they were at specific, measurable, and terrifyingly vast distances. Of the 13,000 stars within our 100-light-year bubble, the vast majority, roughly 75%, are red dwarfs like Proxima and Wolf 359. These stars are the silent majority of the universe. They are the background actors, the steady, long-lived suns that will likely outlast every other structure in the cosmos. As you drift further into relaxation, imagine this neighborhood as a sprawling, three-dimensional map. You are at the center. Around you are the golden suns like ours, the fierce blue giants like Sirius, the white dwarf ghosts, and the teeming billions of red dwarfs. Within this small bubble, we estimate there are at least 4,000 planets, and perhaps as many as 1,000 Earth-sized worlds. Each of those 13,000 stars is a potential home. Each one is a destination. But we are still just at the front door. To truly answer the question of how many stars exist, we must look beyond our neighbors. We must look at the structure they all belong to. We must turn our gaze toward the great, glowing architecture of the Milky Way galaxy. The neighborhood is quiet now. The local lanterns are fading as we pull back, further and further, until the 13,000 stars blur together into a single, faint smudge of light. We are leaving the Orion Arm. We are heading for the heart of the galaxy. Section 3rd. The Island Universe. Imagine, as you lie there, that you are rising through the ceiling of our galaxy. The Milky Way is no longer just a hazy band of light across the sky. It has revealed its true form. It is a majestic, rotating disk of fire and dust, a barred spiral galaxy that spans over 100,000 light-years from edge to edge. To get a sense of this scale, remember that if our entire solar system out to Neptune were the size of a U.S. quarter, the Milky Way would be the size of the entire North American continent. Within this continental expanse lies a population that defies the human instinct for counting. current scientific consensus, gathered from missions like the Gaia spacecraft, suggests there are between 100 billion and 400 billion stars in our galaxy alone. Let that number, 400 billion, vibrate in your mind. If you were to give every star in the Milky Way a name, and it took you just 1 second to say each name, you would have to speak for 12,600 years without a single pause for breath. You would have started before the dawn of human agriculture, speaking through the entirety of recorded history, and you would still have thousands of years of names left to utter. As we hover above this island universe, notice the structure. The stars are not scattered at random. They are governed by the elegant laws of orbital mechanics. At the very center lies the galactic bulge, a dense, heart-shaped region where stars are packed so tightly together that the average distance between them is measured in light weeks rather than light years. Here, the stars are old and golden, many of them dating back to the very first billion years of the universe's life. Deep within that bulge, hidden by thick veils of interstellar dust, sits the anchor of our galaxy, Sagittarius A. It is a supermassive black hole, 4 million times the mass of our Sun. While it is not a star itself, it is the gravitational shepherd of our stellar flock. Thousands of stars whip around it at terrifying speeds, some completing an orbit in just a few decades. It is the silent, dark conductor of a 400 billion-piece orchestra. Radiating out from this center are the spiral arms. We live in the Orion Cygnus arm, but there are more prominent branches: the Perseus arm, the Scutum Centaurus arm, and the Sagittarius arm. These are not solid structures like the blades of a fan. They are density waves, regions where the gas and dust are compressed, triggering the birth of new stars. Imagine the color of these arms. They are tinted blue by the population quark stars, massive, hot, young suns that have just emerged from their nebular nurseries. These stars are the energetic youth of the galaxy. They burn with a fierce, sapphire-white light, but their lives are fleeting. They are the candles that burn twice as bright and half as long. Between these arms lie the interstellar media, the vast, lonely voids where the star count drops significantly. But even these voids are not truly empty. They are filled with a thin fog of hydrogen and helium, and microscopic grains of carbon and silicates. This is the raw material of future stars. Every few million years, this gas will clump together, collapse under its own weight, and ignite a new generation of suns, adding to the total tally of our island home. But the Milky Way is even larger than its visible disk. Enveloping the entire structure is the galactic halo. This is a spherical region of space filled with globular clusters, tightly packed balls of up to 1 million stars each. These clusters are like the retirement homes of the galaxy. The stars here are ancient, low in metals, and incredibly stable. They are the population 2 stars, the silent witnesses to the Milky Way's formation. There are about 150 of these clusters orbiting our galaxy, each one a mini-universe of its own, contributing billions of stars to the final count. As you drift deeper into sleep, imagine the motion of this entire system. Our Sun is traveling at 828,000 kilometers per hour around the galactic center. Even at that staggering speed, it takes us 230 million years to complete just one galactic year. The last time we were in this exact spot in the galaxy, dinosaurs were just beginning to walk the Earth. The next time we return, something entirely different will be looking up at the sky. The count of 400 billion is just the beginning. For every one of those stars, we now suspect there is at least one planet. That means there are 400 billion worlds in our galaxy alone. 400 billion places where a sun rises and sets. But, as immense as the Milky Way is, it is only one of many. We are about to cross the final border of our home. We are moving into the local group, the small cluster of galaxies that includes Andromeda and the Triangulum Galaxy. Beyond that, the numbers begin to grow exponentially, moving from billions into trillions, and eventually into the sextillions. The Milky Way is shrinking now. It is becoming a beautiful, glowing spiral in the rearview mirror of our consciousness. We are entering the true deep, the intergalactic void, where the distance between stars is replaced by the distance between entire universes. Rest in the knowledge that you belong to this 400 billion strong family. You are part of the architecture. You are a citizen of the Milky Way. As we drift further away from the familiar spiral arms of our home, the Milky Way begins to lose its dominance. It shrinks from a horizon-spanning ocean of light into a single, glowing silver coin, floating in an abyss of unimaginable darkness. We are now entering Section 4, the Galactic Zoo, a realm where we stop counting individual stars and start counting entire island universes. To understand the sheer population of the cosmos, we must look at the census of galaxies. For most of human history, we believed that the blurry smudges of light in the sky were merely clouds of gas within our own borders. But in the 1920s, the horizon of our reality exploded. We realized that those smudges were other galaxies, some far larger than our own, separated by gulfs of space so vast that light itself takes millions of years to cross them. Imagine taking a small, dark patch of the night sky, a region no larger than a grain of sand held at arm's length against the blackness. If you were to stare at that empty spot with your eyes, you would see nothing but a void. But if we point a powerful observatory like the Hubble or James Webb Space Telescope at that tiny grain of sand for hundreds of hours, the dark begins to bloom. Thousands of galaxies emerge from the shadows, tiny glowing jewels of every shape and color, amber, sapphire, rose, and brilliant white. If a tiny grain of sand contains thousands of galaxies, think of how many grains of sand it would take to cover the entire sphere of the sky. Based on these deep field observations, astronomers have calculated that there are approximately 2 trillion galaxies in the observable universe. If we assume our Milky Way is an average galaxy with 200 billion stars, and we multiply that by 2 trillion galaxies, we arrive at a number that the human brain simply cannot process. We are now moving into the realm of the sextillion. But before we settle on a final number, look at the diversity within this galactic zoo. Not every galaxy is a perfect spiral like ours. Imagine the ellipticals. These are the giants of the cosmos. They look like glowing golden footballs or soft, hazy clouds of light. They don't have the beautiful sarmal arms or the dust lanes of the Milky Way. Instead, they are swarms of ancient, reddish stars buzzing around a common center like a hive of bees. The largest of these, such as IC 1101, is so massive that it could hold thousands of Milky Ways inside it. It contains over 100 trillion stars on its own. Then there are the irregulars. These galaxies look like splashes of paint against a dark canvas. They are often the victims of cosmic collisions, galaxies that have wandered too close to a neighbor and been torn apart by gravity. In these chaotic regions, gas is compressed so violently that starbirth happens at a frantic pace. These are the starburst galaxies, neon-bright nurseries, where hundreds of new suns are born every year. And, finally, consider the dwarf galaxies. These are the most common residents of the zoo. They are small, faint, and often orbit larger galaxies like loyal satellites. Our own Milky Way has dozens of these mini-galaxies buzzing around it, like the large and small Magellanic Clouds. They might only contain a few billion stars, but their sheer numbers significantly pad the cosmic total. As you lie in the stillness, imagine the local group. This is our immediate galactic family, a collection of about 50 galaxies. Our closest large neighbor is Andromeda, a magnificent spiral currently 2.5 million light-years away. Andromeda is even larger than the Milky Way, holding perhaps 1 trillion stars. Imagine the view from a planet inside Andromeda. The sky would be dominated by a different set of constellations, a different history of light. And yet, Andromeda is falling toward us. In about 4 billion years, our two galaxies will begin a slow, graceful dance, eventually merging to form a single, massive elliptical galaxy. This is the fate of many stars, to be part of a changing, evolving structure that grows larger and more complex over eons. Beyond the local group, galaxies are organized into superclusters. These are the largest structures in the universe, great filaments of light that stretch for hundreds of millions of light-years. We live in the Laniakea supercluster, a name that means immeasurable heaven in Hawaiian. It contains 100,000 galaxies. Think of those 100,000 galaxies as a single neighborhood in the 2 trillion available. The numbers are becoming heavy, but let that weight feel like a warm, thick quilt. You are not lost in this vastness, you are a witness to it. Every one of those 2 trillion galaxies is filled with the same fundamental elements that make up your body. The hydrogen in the water in your cells was forged in the same Big Bang that created those distant spirals. The iron in your blood was cooked in the hearts of stars and galaxies whose names we will never know. As we conclude this section, imagine the light from those 2 trillion islands traveling through the vacuum. It moves at 300,000 kilometers per second, yet for the most distant galaxies, that light has been traveling for over 13 billion years. We are not just looking at a zoo of objects, we are looking at a gallery of history. We are seeing the universe as it was when it was a mere infant. The scale is expanding, and your awareness is expanding with it. The Milky Way is now just a single grain of light among trillions. The count is rising. The stars are multiplied by galaxies, and the galaxies are multiplied by clusters, until the light becomes a solid, glowing fog of existence. Nefes Veran. Let the 2 trillion galaxies settle into the background of your mind. In the next section, we will confront the math directly. We will look at how we calculate the uncalculable and try to find the final, staggering sum of all the stars in the night. We have ventured through the local neighborhoods and stood atop the peaks of galactic superclusters. Now, we must confront the sheer magnitude of what we have seen. We enter Section VIII, the math of the infinite, where we bridge the gap between human observation and the staggering reality of cosmic scales. How do we count what we cannot even see? As you lie there, perfectly still, consider the challenge facing astronomers. We cannot simply point a telescope and click a tally counter for every star in the sky. To do so for even our own galaxy would take lifetimes. Instead, we use a method of representative sampling, a beautiful marriage of mathematics and physics that allows us to weigh the universe itself. First, we must determine the mass of a galaxy. By observing how quickly a galaxy rotates, we can calculate how much gravity is required to hold it together. Since gravity comes from mass, we can determine the weight of a galaxy. From that total weight, we subtract the estimated mass of gas, dust, and the mysterious dark matter. What is left is the mass of the stars. We then use our sun as a yardstick. Our sun is what we call one solar mass. By dividing the total stellar mass of a galaxy by the average mass of a star, we arrive at a count. It is a celestial census taken not by seeing every face, but by measuring the weight of the crowd. When we apply this math to the 2 trillion galaxies we identified in the previous section, the number that emerges is 200 sextillion. To write it out, you would place 21 zeros after the number 200, 200,000, 1,000, 1,000, 1,000, 1,000, 100,000. To make this number tangible, let us return to the analogy we touched upon earlier, the sands of the earth. Imagine you are walking along a beach at sunset. The sand beneath your feet is composed of tiny individual grains, fragments of shells, volcanic rock, and ancient mountains ground down by the relentless rhythm of the tides. If you were to take a single thimble of that sand, you might hold about 10,000 grains. If you were to walk the entire length of that beach, from the dunes to the shoreline, you would be walking over billions. Now, expand your mind to every beach on the planet. The vast Sahara Desert, the shifting dunes of the Gobi, the white sands of the Caribbean, and the volcanic black shores of Iceland. Scientists estimate that there are roughly 7 quintillion, 500 quadrillion grains of sand on Earth. It is a number so large it feels like it should represent everything. And yet, for every single grain of sand on our entire planet, there are 10,000 stars in the observable universe. Imagine picking up a single grain of sand from a beach in Florida. That one grain represents your life, your home, your world. Now imagine that for that one grain, there is an entire beach's worth of stars out there in the dark. 10,000 suns for every single grain of sand on our world. But even this math has its limitations, and as you relax further, let this thought settle into your consciousness. We only know about the observable universe. The universe is 13.8 billion years old. Because light has a speed limit, 300,000 kilometers per second, we can only see the light that has had enough time to reach us since the beginning of time. This creates a light horizon, a sphere around us with a radius of about 46 billion light-years, accounting for the expansion of space. But what lies beyond that horizon? Most cosmologists believe that the universe does not simply stop where our vision ends. If the universe is flat, as our current measurements suggest, it could be infinite. If the universe is infinite, then the number of stars is not 200 sextillion. It is not even a number at all. It is an endless repetition of suns, galaxies, and possibilities, stretching out forever into a dark that never concludes. As you breathe in, imagine the finitude of your room. As you breathe out, imagine the infinity of the math. There is something deeply comforting about these numbers. They are so large that they strip away the significance of our small anxieties. In a universe of 200 sextillion suns, the fact that you missed a deadline or felt a moment of social awkwardness becomes as thin and unimportant as a single atom of hydrogen in a nebula. We also have to account for the extraterrestrial background light. This is the faint, ambient glow of all the stars that have ever existed, even those we cannot resolve into individual points. By measuring this fossil light, astronomers can check their math. They look at the darkness of the sky and realize it isn't truly dark. It is filled with the sum total of every photon ever emitted. Our current math tells us that the universe is actually dimming. Most of the stars that will ever exist have already been born. We are living in the stelliferous era, the age of stars. Eventually, many trillions of years from now, the gas will run out, the fusion will stop, and the lights will go out, one by one. But that is a story for a different night. Tonight, the count is at its peak. The universe is a crowded, luminous, and vibrant place. Whether it is 200 sextillion or an absolute infinity, the result is the same. You are never truly alone in the dark. You are surrounded by a number of lights that exceeds the capacity of any human heart to hold. Let the math wash over you like a gentle tide. You don't need to calculate. You don't need to solve for x. You only need to exist within the sum. As we prepare to move into the next section, we will shift our focus from the quantity of stars to their quality. We will look at the genealogies of these stars, the different generations of suns, and how they have changed over the eons to make life possible. We have contemplated the staggering numbers, the sextillions of points of light that populate the dark. But a star is more than just a digit in a cosmic census. To truly understand how many stars exist, we must understand what those stars are made of, and how they have changed over the vast stretches of time. We now enter Section 6, Stellar Genealogies. In the silence of the night, it is easy to imagine that the stars have always been there, unchanging and eternal. But stars have ancestors, they have lineages, and the stars we see today are very different from the stars that first lit up the primordial gloom of the infant universe. Think back to the very beginning, roughly 13.8 billion years ago. The universe was a hot, dense soup of energy. As it expanded and cooled, the first atoms formed, mostly hydrogen, some helium, and a tiny trace of lithium. There was nothing else. No carbon for life, no oxygen to breathe, no iron for the core of a planet. The universe was chemically pure, but it was also dark. Then came the population 3 stars. These were the first generation, the pioneers. We have never seen one directly, even with our most powerful telescopes, because they lived and died billions of years before the Earth was born. But we know they must have existed. These were the firstborn, giants of unimaginable scale. Some were hundreds, perhaps even 1,000 times more massive than our Sun. Because they were so massive, they burned through their fuel with a terrifying blue-white ferocity. They lived for only a few million years, a mere blink in cosmic time, before exploding in hypernova. In those final, violent moments, they did something miraculous. They fused the simple hydrogen and helium into the first heavy elements. They created the first carbon, the first nitrogen, the first oxygen. They seeded the universe with the building blocks of complexity. As these giants died, they left behind clouds of polluted gas. Out of these clouds, the population 2 stars were born. These are the elders of the modern universe. We can still see them today, mostly in the globular clusters that orbit the centers of galaxies. These stars are billions of years old, survivors from the early days of the Milky Way. They are metal-poor, meaning they still consist mostly of the original hydrogen and helium, with just a faint dusting of the heavier elements left by the population 3 ancestors. When you look at a globular cluster through a telescope, you are looking at a fossil. These stars are stable, patient, and incredibly long-lived. They represent a time when the universe was just beginning to organize itself into the galaxies we recognize today. Finally, we come to the population-wide stars, like our own Sun. These are the youngest generation, the metal-rich stars. They were born from gas that had been recycled through multiple generations of previous stars. Every time a star dies, it exhales its inner chemistry back into space. Our Sun is the product of billions of years of cosmic recycling. Think about what this means as you lie there in the quiet. Every atom of iron in your blood, which allows you to carry oxygen to your brain, was forged in the heart of a dying star billions of years ago. The calcium in your teeth, the silicon in the soil, the gold in a wedding ring, all of it is stardust. You are not just an observer of the stars. You are a physical extension of their life cycles. The count of stars is, therefore, a count of generations. The 200 sextillion stars are not all the same age. Some are ancient veterans from the dawn of time, while others are protostars, currently coalescing in the heart of a nebula like the famous Pillars of Creation. Imagine a nebula as a vast celestial womb. It is a place of chaos and beauty, where pillars of cold hydrogen gas light up with the internal fire of newborn suns. Here, the number of stars in the universe is actively growing. In our own galaxy alone, several new stars are born every single year. Across 2 trillion galaxies, that means that in the time it takes you to blink, thousands of new suns have just ignited their nuclear fires for the first time. But for every birth, there is a transition. In the next movement of our journey, we must look at the stars that are no longer stars in the traditional sense. We must look at the remnants, the ghosts that haunt the light. We must consider how the count changes when we include the stars that have passed into the great silence. Feel the weight of your own body again, and remember that you are made of the same material as these 3 generations of suns. You are the universe becoming aware of its own genealogy. You are the descendant of giants. As the light of the young blue stars and the old golden suns mingles in your mind, prepare to move into the more mysterious reaches of the Census. We are going to look at what remains when the fire goes out, as we pull our gaze away from the vibrant nurseries of the nebulae and the bright generations of living suns. We must acknowledge a somber but beautiful truth. The census of the universe is not just a count of the living. To truly grasp the scale of what exists, we must look into the shadows. We now enter Section 7, the ghost stars. When we look at the night sky, we see the survivors. We see the stars that are currently winning their battle against gravity. But for every star shining brightly tonight, there are millions of others that have already finished their journey. They have exhausted their fuel, breathed their last breath of light, and transformed into something else entirely. These are the remnants, the ghosts of the cosmos, and they are just as much a part of the total count as the suns that warm our planets. The first type of ghost is the white dwarf. Imagine a star like our Sun. For billions of years, it is a stable, reliable source of life. But eventually, it will run out of hydrogen in its core. It will swell into a red giant, consuming its inner planets, before gently shedding its outer layers like a translucent silk veil. What remains is the core, a white-hot, ultra-dense sphere of carbon and oxygen about the size of the Earth, but with the mass of a sun. There are billions upon billions of these white dwarfs in our galaxy alone. They do not produce new energy. They are simply cooling embers. If you could stand on the surface of a white dwarf, the gravity would be 100,000 times stronger than on Earth. Your body would be crushed into a layer of atoms thinner than a sheet of paper. These stars are silent, patient, and nearly eternal. It will take trillions of years for a white dwarf to lose its heat and become a black dwarf, a cold, invisible diamond floating in the void. Since the universe is only 13.8 billion years old, not a single black dwarf has had time to form yet. Every white dwarf that has ever been created is still out there, glowing with the residual warmth of its former life. But for the massive stars, the end is much more violent. When a star significantly larger than our Sun dies, it doesn't fade away. It collapses inward in a fraction of a second, triggering a supernova explosion that can briefly outshine an entire galaxy. What is left behind is a neutron star. A neutron star is one of the most extreme objects in the known universe. Imagine taking a mass twice that of our Sun and crushing it down until it is only 20 kilometers wide, the size of a small city. The material inside is so dense that the atoms themselves have collapsed. The electrons and protons have been crushed together to form a solid mass of neutrons. These ghosts are often found spinning at incredible speeds, hundreds of times per second, sending out beams of radiation like a cosmic lighthouse. We call these pulsars. When we count the stars in the universe, we must count these spinning ghosts. There are estimated to be hundreds of millions of neutron stars in the Milky Way, most of them drifting silently and invisibly through the dark, their presence known only when they pass in front of a distant light or pull on a nearby neighbor. And then there are the ultimate ghosts, the black holes. When the most massive stars of all die, not even the strength of neutrons can stop the collapse. They fall into themselves until they occupy zero volume but retain infinite density. They are stars that have reached the end of physics. While they emit no light of their own, they are a vital part of the stellar population. They are the remnants of the blue giants we discussed earlier, the final resting place of the most energetic matter in the universe. Why do these ghosts matter to our count? Because they represent the missing light. When we calculate that there are 200 sextillion stars, we are often counting the ones currently emitting light. But if we were to count every star that has ever existed since the Big Bang, that number would be significantly higher. Imagine the universe as a vast, dark forest. Some trees are vibrant and green, some are changing color, and some have fallen to the forest floor to become part of the soil. To understand the forest, you cannot just count the green leaves. You must understand the entire cycle of growth and decay. As you lie in the stillness of your room, let the idea of these ghost stars bring you a sense of profound continuity. Nothing in the universe is ever truly lost. The matter is simply rearranged. The light of a star that died 5 billion years ago is still traveling through the vacuum, and its physical heart is still out there, a dense and silent monument to the power of gravity. We are part of a universe that remembers its past. The ghosts are all around us, invisible but influential, holding the galaxies together with their silent gravity. In the final movement of our journey, we will bring all these scales together. We will return from the black holes and the white dwarfs to the simple reality of our own breath. And we will find peace in the final, staggering sum of the cosmos. We are now standing at the precipice of the truly immense. We have navigated the local neighborhoods, scaled the heights of the galactic structures, and paid our respects to the ghosts of the stellar graveyard. Now, We must synthesize this information into a single, cohesive vision of reality. We enter Section 8, the scale of stillness. This is the point where numbers transition from mathematics into a form of meditation. When we speak of 200 sextillion stars, we are no longer talking about something the human mind can visualize. If you were to try and visualize 200 sextillion individual points of light at once, your mind would simply see a solid wall of white. And, in a way, that is the truth of the universe. If the universe were infinite and static, every line of sight from your eye would eventually land on the surface of a star. The night sky would not be black. It would be as bright as the surface of the sun. This is known as Olbers's paradox. The reason the sky is dark. Reason you can lie in your room and enjoy the velvet shadows is because the universe is expanding, and because it has a beginning. The light from the most distant of those sextillions of stars hasn't reached us yet, or it has been stretched by the expansion of space into infrared wavelengths that our eyes can no longer perceive. As you lie there, imagine the stillness of this expansion. It is a silent, relentless stretching of the fabric of space-time. Between every galaxy, new space is being created every second. This means the count of stars is not a static number, it is a fading one. Galaxies are moving away from us so fast that their light will eventually be unable to cross the gap. In the far, far future, an observer on Earth, or whatever Earth has become, will look up and see nothing but an empty, black void. The 200 sextillion stars will still be there, but they will be forever beyond the horizon of the reachable. We are living in the golden age of starlight. We are at the perfect moment in cosmic history, where the universe is old enough to have formed trillions of galaxies, but young enough that they are still visible to us. Let's look closer at the cosmic web. This is the largest scale of the universe we have ever mapped. If you could zoom out until the 2 trillion galaxies were just tiny dots, you would see that they aren't scattered like dust. They are organized into long, glowing filaments, like the threads of a spider's web, or the neurons in a giant cosmic brain. In the intersections of these filaments lie the superclusters, the metropolitan hubs of the universe where tens of thousands of galaxies huddle together. And between these filaments are the voids, vast, empty bubbles of nothingness that can be hundreds of millions of light years across. In these voids, the star count drops to almost zero. They are the great deserts of the cosmos. Imagine drifting through one of these voids. For millions of years, you would see nothing but darkness. No stars, no galaxies, no light. Then, gradually, a faint glow would appear on the horizon, the edge of a filament, a shimmering wall containing trillions of suns. This contrast between the absolute empty and the infinitely crowded is the heartbeat of the universe. How does this scale affect our sense of self? Often, when people contemplate the 200 sextillion stars, they feel small. They feel insignificant. But I want you to consider a different perspective. You are a complex biological machine capable of contemplating the 200 sextillion. You are a collection of stardust that has gained the ability to count the stars. In the entire observable universe, we have yet to find another place where the atoms have arranged themselves in such a way that they can ask, how many? The stars are massive, yes. They are hot, they are old, and they are numerous. But they are mindless. A star cannot wonder about its neighbor. A galaxy cannot map its own spiral arms. You, in the quiet of your room, are the eye of the universe. You are the way the cosmos looks at itself and tries to understand its own scale. As we conclude this section, let the scale of stillness wrap around you. The universe is huge, but it is not chaotic. It is governed by laws, gravity, electromagnetism, the strong and weak nuclear forces that are the same here in your room as they are in a galaxy 13 billion light-years away. The same physics that makes your heart beat is the physics that makes the stars shine. There is a profound peace in this uniformity. You are a part of a coherent, interconnected system. Whether there are 100 billion stars or 200 sextillion, they all obey the same master. They all dance to the same music. Take a deep breath. We have reached the peak of our climb. We have seen the numbers, the math, the history, and the structure. Now it is time to begin our descent. In the final movements of our script, we will move toward the cosmic stillness, the final conclusion where we let the numbers go and simply exist in the glow of the night. We are now moving beyond the present moment. We have counted the stars that exist today in this fleeting golden age of the universe. But to truly understand the nature of the stellar population, we must look at the arrow of time. We enter Section 9, the evolution of light and the final census. As you lie in the quiet of your room, it is tempting to think of the 200 sextillion stars as a permanent fixture of reality. But the universe is a living, breathing process, and the count we have discussed is a moving target. We are currently living in what astronomers call the stelliferous era, the age of stars. It is a period that began about 200 million years after the Big Bang and will continue for many trillions of years. But it is not infinite. Imagine the universe as a vast reservoir of fuel. At the beginning, that reservoir was full of pristine hydrogen gas. Over the last 13.8 billion years, gravity has been draining that reservoir, turning that gas into the glowing furnaces we call stars. But the rate of star formation is not what it used to be. The universe reached its peak of star birth about 10 billion years ago, a period known as cosmic noon. During that time, galaxies were creating stars at a rate nearly 10 times faster than they are today. We are now in the afternoon of the universe. The great nebulae, those vast, colorful clouds like the Orion Nebula or the Pillars of Creation, are slowly being depleted. Every time a star is born, it locks away a portion of that gas. When a star dies, it returns some of it to the void, but much of that material is poisoned with heavier elements, or locked away forever in the dense, cold hearts of white dwarfs and black holes. This means that the number of stars in the universe is, in the very long term, a declining currency. But there is a beautiful, slow grace to this decline. As the massive, short-lived blue stars die out and the gas reservoirs shrink, the universe will increasingly be dominated by the red dwarfs. As we mentioned before, these are the smallest and coolest of the true stars. Because they are so efficient and burn their fuel so slowly, a red dwarf born today might still be shining 10 trillion years from now. To put that into perspective, the universe is currently 13.8 billion years old. If the entire life of the universe so far was just one single day, the red dwarfs born this morning will continue to shine for another 1,000 years. As the larger galaxies like the Milky Way and Andromeda merge and settle into massive, quiet elliptical galaxies, the star count will become more stable. These future galaxies will be filled with trillions of these small, ancient red suns. They will provide a faint, amber light to the cosmos for an unfathomable stretch of time. Imagine a distant future observer, trillions of years from now. By then, the expansion of the universe will have pushed all other galaxies beyond the horizon of visibility. This observer will live in a universe that appears to consist of only one giant galaxy, filled with aging red stars. To them, our current era, with its trillions of visible galaxies and its violent, bright blue stars, will seem like a myth, a legendary time of light that existed in the distant past. But even the red dwarfs must eventually fade. There will come a moment, perhaps 100 trillion years from now, when the very last star in the universe ignites. It will likely be a tiny red dwarf in a remote corner of a dying galaxy. It will burn for a few billion years, a lonely candle in an increasingly dark house. And when that star finally exhausts its hydrogen, it will shrink into a white dwarf, and the stelliferous era will come to an end. The universe will then enter the degenerate era. The count of stars will technically drop to 0, replaced by a count of remnants: white dwarfs, neutron stars, and black holes. These objects will linger for durations that defy human language, numbers with so many zeros that they would fill books. Why do we contemplate this end while trying to sleep? Because it gives the 200 sextillion stars we see tonight a profound sense of value. They are not just random points of light. They are a temporary gift of the cosmos. They are a phase. We are lucky enough to exist during the blink of an eye when the universe is illuminated. Feel the warmth of your own life, your own fuel burning within you. Just as a star converts its inner mass into light and heat, you are converting your experiences, your thoughts, and your breaths into a life. You are a part of the stelliferous era. You are a participant in the age of light. The evolution of light is a reminder that everything, from the smallest atom to the largest galaxy, has a story with a beginning, a middle, and an end. The fact that the lights will eventually go out makes the fact that they are on right now all the more miraculous. As you settle deeper into your pillows, let the vast time scales of the future act as a weight, pulling you down into a deep, dreamless rest. The stars have a long way to go before they fade. They will be there for all of human history and far beyond. You can let go of the vigil. You can stop watching the horizon. The universe is in its long, slow afternoon, and there is plenty of light left for us to find our way to sleep. We are nearing the final horizon of our journey. But before we allow the light to dim completely, we must look at the fine details, the very threads that weave these sextillions of stars into the physical reality we touch every day. We enter Section X, the chemistry of the infinite. When we look at a star, we aren't just looking at a ball of fire. We are looking at a laboratory of the most extreme alchemy. In the quiet of your room, look at the objects around you: the metal in your bedside lamp, the oxygen you are breathing, the carbon that forms the very structure of your DNA. None of these things existed when the universe began. To understand how many stars there are, we must understand that each one is a factory, and the count of stars is directly tied to the count of life. Every star is a delicate balance of pressure and temperature. At the core of a star, the heat is so intense that electrons are stripped from their atoms, creating a roiling sea of plasma. Here, under the high weight of an entire sun, hydrogen nuclei are forced to fuse. This is the simplest form of stellar alchemy, 2 protons becoming a nucleus of helium. But as a star ages, and especially in the more massive stars among our 200 sextillion, the alchemy becomes more complex. When the hydrogen runs out, the star begins to cook the helium. Helium atoms fuse to create carbon. Carbon fuses to create neon, then oxygen, then silicon. Each layer of the star becomes a different stage of the periodic table. Imagine a massive star as a celestial onion. The outer layer is still hydrogen, but as you go deeper, you pass through layers of increasingly heavy elements. At the very center, in the hottest, most pressurized heart of the star, it begins to create iron. Iron is a unique element in the universe. It is the ash of nuclear fusion. Fusing iron doesn't release energy, it consumes it. The moment a star creates iron in its core, its fate is sealed. The outward pressure that has held the star up for millions of years vanishes. The star collapses in on itself in a fraction of a second, rebounding in a supernova explosion that scatters those newly forged elements, the carbon, the oxygen, the gold, and the iron across the galaxy. This process is called nucleosynthesis, and it is the reason that how many stars exist is such a vital question for our own existence. If the universe had only formed a few million stars, there wouldn't be enough polluted gas to form planets. You need billions of stars to live and die over billions of years to enrich the cosmic clouds with enough heavy material to build a world like Earth. We are the beneficiaries of a massive, multi-generational construction project. The 200 sextillion stars are not just lights. They are the ancestors that died so that we could be born. Think about the iron in your blood. That specific atom of iron, which is currently carrying oxygen to your brain as you listen to my voice, was forged in the heart of a massive star that exploded billions of years ago. It traveled through the vacuum of space, settled into a cloud of gas, became a part of our sun's nursery, was incorporated into the cooling earth, and eventually found its way into the food you ate and the blood that keeps you alive. You are quite literally a piece of the stars looking back at them. This chemical connection also explains the colors of the stars. When you look at the night sky, notice that some stars have a faint blue tint, while others look orange or yellow. This isn't just about temperature, it's about their metallicity. A star's spectrum, the barcode of light it sends out, tells us exactly what it is made of. By reading these barcodes, we have learned that the stars in the distant past were different. They were simpler. As we move toward the final count, consider the spectroscopy of the night. Across the 2 trillion galaxies, there are stars made of things we are still trying to understand. There are carbon stars with atmospheres so thick and soot-like that they glow a deep ruby red. There are Wolf-Rayet stars that are blowing themselves apart with winds a billion times stronger than a hurricane. The number 200 sextillion is not a count of identical objects. It is a count of a diverse chemical family. Every star has a unique fingerprint. Every star has a different ratio of elements. As you settle into the deepest part of your relaxation, imagine the sheer volume of material these stars have created. In our galaxy alone, there is enough stardust to create billions of Earths. The universe is not a sterile void. It is a fertile garden, and the stars are the trees that drop the seeds of life into the dark. The chemistry of the infinite is a chemistry of connection. You are made of the same stuff as the furthest galaxy in the Hubble Deep Field. You share a common ancestry with the most distant quasar. Feel the weight of that history in your limbs. You are heavy with the legacy of a billion suns. Your body is a vessel for the elements they fought to create. As you breathe out, imagine you are returning a tiny bit of that carbon back to the world, a small contribution to the ongoing cycle of the cosmos. Rest now, knowing that the stars are not just out there, they are in here. They are the reason you have a heart to beat and a mind to dream. We have counted the giants, the ghosts, and the chemical factories that illuminate the void. But as we move toward the final summation of our journey, we must acknowledge that our count so far has been biased. We have been counting the winners of the cosmic lottery, the objects bright enough to be seen. Now we enter section 13, the invisible multitude. In the quiet of your room, you might think that the space between the stars is empty. But if we could truly see the universe in its entirety, we would realize that for every brilliant star we've counted, there are likely dozens of almost stars and dark suns that linger in the shadows, invisible to the naked eye and even to many of our best telescopes. The first members of this invisible multitude are the brown dwarfs. Astronomers often call these failed stars, but that is perhaps too harsh a title. They are better described as the bridge between the largest planets and the smallest stars. A brown dwarf forms just like a star from a collapsing cloud of gas and dust. But it never quite gathers enough mass to trigger the sustained nuclear fusion of hydrogen in its core. It is a world caught in a permanent twilight. It is too massive to be a planet like Jupiter, but too small to ignite its own internal fire. Imagine floating near one of these objects. It would not glow with the blinding white light of our sun. Instead, it might emit a deep, dull magenta or a dark, moody red. Many brown dwarfs are so cool that they have atmospheres with clouds made of liquid iron or silicate dust. Some are even cool enough to have clouds of water vapor, yet they are massive enough to crush anything that tried to land on them. How many of these failed stars are out there? Because they are so dim, they are incredibly difficult to find. We have only begun to detect them in the last few decades using infrared sensors like those on the Wide Field Infrared Survey Explorer, WISE. Recent estimates suggest that there may be as many brown dwarfs in the Milky Way as there are regular stars. Think about that. If there are 400 billion stars in our galaxy, there might be another 400 billion of these dark, smoldering giants drifting in the spaces between them. They don't contribute much light to the 200 sextillion count, but they represent a massive, silent population that fills the suburbs of every galaxy. But the invisible multitude goes even deeper. We must also consider the rogue planets. For a long time, we thought planets only existed in orbit around stars. But we now know that in the chaotic early years of a solar system's life, planets are often thrown out into deep space by the gravity of their larger siblings. These are the orphans of the cosmos. They drift through the interstellar void, far from the warmth of any sun. Recent studies suggest that for every star in the Milky Way, there could be dozens of these rogue planets. If we include these in our census of celestial bodies, the numbers swell from the sextillions into the septillions. While they aren't stars, they are part of the same creative process. They are pieces of the same puzzle. As you lie in the stillness, imagine the dark between the stars is actually a crowded place. It is a hidden landscape of cold giants, rogue worlds, and dark matter. This brings us to a humbling realization about our count. Everything we have discussed tonight, the 200 sextillion stars, the galaxies, the nebulae, the brown dwarfs, only accounts for about 5% of the total mass and energy in the universe. The rest is dark matter and dark energy. We cannot see dark matter. It does not emit light, reflect it, or absorb it. We only know it is there because of its gravitational pull on the stars we can see. It is the invisible scaffolding of the universe, the web upon which the 200 sextillion stars are hung like holiday lights on a tree. Without this invisible multitude, the stars would simply fly apart. The galaxies would not hold their shape. The count would be 0. As you settle into your bed, let the idea of the invisible provide a sense of mystery and protection. Just because you cannot see something doesn't mean it isn't there, supporting the structure of your world. Much like the quiet air in your room or the steady beat of your heart, the most important parts of the universe are often the ones that make the least noise. We are almost at the end of our tally. We have looked at the bright, the dead, the ancient, and the hidden. In the final movement, we will bring our focus back to the smallest scale, back to you, and find the peace that comes with knowing your place in this 200 sextillion star story. Nefes Veran. The dark is not empty. It is a vast, supportive presence, filled with the potential for everything we have yet to discover. We have reached the edge of the map. We have traversed the distances between atoms and the gulfs between galaxies. We have looked at the light that was, the light that is, and the ghosts that linger in the dark. Now, we begin our final descent. We enter section XIII, the final summation and the descent into stillness. As you lie here, fully surrendered to the weight of your body and the quiet of the room, let the number 200 sextillion become a soft, rhythmic pulse in the background of your mind. It is no longer a math problem. It is the heartbeat of a living cosmos. When we ask how many stars exist, we are really asking, how much room is there for possibility? With 200 sextillion stars and potentially even more planets, the universe is a garden of infinite variety. Somewhere out there, at this very moment, a star is being born in a pillar of emerald gas. Somewhere else, a massive blue sun is collapsing into a black hole, drawing the final curtain on a short, brilliant life. Somewhere, perhaps, another being is looking up at their own version of a night sky, wondering about the same numbers, feeling the same sense of awe and quietude. But let us bring the focus back closer. Bring it back from the trillions of galaxies and the billions of light years. Bring it back to the Milky Way, back to the Orion Arm, back to our sun, and finally, back to this room. The most incredible thing about the 200 sextillion stars is not their number. It is the fact that they are all made of the same fundamental materials as you. The laws of physics are not different in the Andromeda Galaxy. Gravity doesn't work differently in the Boötes Void. The universe is a single, coherent whole. It is a vast, interconnected web where every piece, no matter how small, is vital to the integrity of the total. If you were to remove even one of those 200 sextillion stars, the gravitational balance of the universe would shift, however slightly. You are a part of that balance. You are a localized point of consciousness within this immense system. You are the universe's way of experiencing itself. As you drift toward the final stages of wakefulness, imagine the light of all those stars as a gentle, warm pressure. It isn't a blinding light anymore. It's a soft, ambient glow, the extragalactic background light. It is the sum total of all the stories ever told by the stars. It is a light that carries no demands. It doesn't ask you to do anything, to be anything, or to solve anything. It simply exists. Feel your breath slowing even further. Every time you exhale, Imagine you are releasing a tiny bit of the tension that comes from living in a world of deadlines and clocks. In the world of the 200 sextillion stars, time is measured in billions of years. A human life in that scale is a beautiful, bright spark, a supernova of consciousness that is precious precisely because it is so brief and so brilliant. Think of the silence of the vacuum. It is a perfect, healing silence. It is the same silence that is now filling your room. Let it wrap around you like a protective shield. No noise can penetrate this depth. No worry can survive this scale. The stars are the ultimate watchers. They have seen the birth of planets and the death of civilizations. They have seen the first life crawl out of the oceans on Earth, and the first eyes look up at them in wonder. And tonight, they are watching over you. Not with judgment, but with the steady, unwavering presence of something that has always been and will be for a very, very long time. As your mind begins to wander into the landscapes of dreams, let the numbers dissolve. Let the sextillions, the trillions, and the billions fade away. All that remains is the feeling of being home. You are a child of the stars, resting in the cradle of the infinite. The tally is complete. The lights are dimmed. The universe is at peace, and you are a part of that peace. One last deep breath. Inhale the stardust. Exhale the night. The stars will continue their work while you sleep. They will keep burning, keep fusing, and keep shining across the billion-year voids. You have done your part. You have observed. You have wondered. You have counted. Now, it is time to simply be. Movement. The final call to the night. As we close this chapter of the Science Pillow, let the vastness of the cosmos remain with you as a source of comfort rather than overwhelm. The universe is large, but it is also intimate. Every star you've heard about tonight is a testament to the beauty of the laws that govern us all. If you found peace in this journey through the 200 sextillion stars, I invite you to gently like this video and subscribe to our channel. By joining the Science Pillow, you become part of a community dedicated to the quiet exploration of the mysteries that surround us. We have many more journeys planned, into the depths of the oceans, back to the dawn of the dinosaurs, and into the strange electrical corridors of the human mind. But for now, there is only the dark, the stars, and the rest you have earned. The night is long, the universe is wide, and you are exactly where you need to be. Sleep well, traveler. The stars are watching.